In this video, I'm going to teach you a deep neural network model that uses the TensorFlow library to predict the next candle. This deep neural network model is going to predict whether the next candle will be bullish or bearish. Deep learning is the cutting edge of artificial intelligence. I will show in this video how we are going to use deep learning in algorithmic trading. Deep learning uses a lot of concepts. I'll try to explain in simple terms those concepts in this video and in subsequent videos also. So don't worry if you don't understand a concept in this video. In the subsequent videos, I'll again revisit those things and explain them in detail. Trading is all about predictions. We predict the price, whether it's going to go up and down. If we think the price is going to go up, we buy. And if we think the price is going to go down, we sell. What we want is we want a high win rate so that most of the time we win. And this is the only way to make money. If you keep on losing, then of course you're not going to make any money. In order to have a high win rate, we develop models. In the past, technical analysis was being used to predict price. Now, with the recent advancements in computation, we have got machine learning and deep learning also. In statistics, once we make a model, we have to first decide the probability distribution, which is a difficult thing because returns in financial markets are distributed in a long tail distribution. And most of the time, people have been using normal distribution, which is not a long tail distribution, which ultimately predicted things that people later on lost a lot of money acting on those predictions. The advantage of deep learning is this, that we are not assuming anything about the probability distribution. We just give that model the past data, and deep learning model will itself read that data and then make a model and then tell us that what is the prediction according to that deep learning model. So we don't make any assumptions, something that is very powerful. So let's start. So this is a Euro-Yen chart. We are thinking of opening a trade here. We want to know whether this candle that is now being formed is going to be a bullish candle or bearish candle. If we want, let's say we want to open a short trade, and if our model predicts that it is going to be bullish candle, then we should avoid opening a short trade. If you have watched my previous video on MACD trading strategy, I told you how we use MACD in determining the trend. MACD is bullish. So it seems that short trade at this moment is not a good idea. And this is the daily chart. That was the H12 chart. On daily chart also, MACD is bullish. So we want to know whether we are going to have a bullish candle or a bearish candle. Since this H12 chart, on this H12 chart, MACD is bullish. On H8, it is bearish. So should I open a long trade? Let's see how we solve this problem. We solve this problem by developing a deep neural network. I have coded this deep neural network. It will predict the next candle, any currency pair, any stock, any time frame. So we'll just use this model. This model works for all time frames, all currency pairs, all stocks. So from date time, import date time, then we import MetaTrader 5 as MT5. This is the API that connects Python with the MT5, and we can then seamlessly download data any time frame, any currency pair stock from MT5. Before watching this video, you should watch my video on how to connect Python with MT5, in which I've explained about this MetaTrader 5 API. You should also watch my video on Pandas for algorithmic trading, Taleb Python library for technical analysis, and NumPy for algorithmic trading. After you have watched these 3 videos, then you should watch this video and you'll find that you'll easily understand most of the things in this video. So I hope you have watched the previous videos. We import Pandas as PD. This is a PD is an alias. We import NumPy as NP. We import TensorFlow as TF. TensorFlow is a very powerful deep learning library, open source library developed by Google. Google developed this TensorFlow library. In the beginning, they used this TensorFlow library for their inner work for deep learning, machine learning. And after a few years, when this TensorFlow library was mature and very powerful, they decided to open source it. Now we can use it. We can easily install it. I've installed it. You will just install it using pip install TensorFlow. My computer has got GPU, NVIDIA card. So TensorFlow GPU is very fast. I have not installed that TensorFlow GPU. I'll be using just simple TensorFlow. From TensorFlow, the Keras.models import sequential. Keras is a layer built on TensorFlow. It's a higher abstraction level, gives you a higher abstraction level. Sequential means that we will have layers. But once layer calculates, then it gives that data to the second layer. Then once it calculates, that it can give the layer to the third layer, and it will be like that. So in a sequence, the data will flow. First layer will make the calculations, then it will give it those the result to the second layer. It will make the calculation and give the result to the third layer. It will make the calculation that give the result to fourth layer. And we will decide in the model how many layers we are going to have. Each layer is known as dense. Dense, I'll explain again. From Keras.layers, import dense and LSTM. LSTM is a long short-term memory. It's a recurrent neural network. It's an advanced concept. In time series, what we have is there's some memory in the past values. So researchers built recurrent neural networks that also use that past values in determining the present value. So long short-term memory is a architecture that we will be using, and we'll be using dense also. And from TensorFlow Keras that optimize and import Adam. Adam is a stochastic gradient descent type of thing. Stochastic. Most of these deep learning models use gradient descent in order to reduce the time of calculation. We use stochastic gradient descent. Stochastic means where we randomly choose values and then calculate the gradient. If you have taken calculus, gradient is just the slope of the curve. So we want to move in the downside and want to identify the valley because we'll be minimizing our loss. I hope this explanation makes things a little bit clear to you somewhat. First, we define the rates function. This is consider time frame bars. We will be downloading the data from MT5 Live, as I've said in the beginning. MyBroker provides stocks also on MT5, cryptocurrencies also, futures also, commodities also. So currency pair, instead of currency pair, I should have used instrument, but since I have now written this currency pair, let's keep on using it. But MT5 now is a very powerful platform, and MyBroker provides stocks also listed on New York Stock Exchange, NASDAQ. It provides commodities also, gold, silver, oil, natural gas. It provides futures also. It provides cryptocurrencies also. There are Bitcoin, Ethereum, Litecoin, Ripple. We can use anything that MT5 symbol window provides here. So I should have used instrument, but since I've used currency pair, so we will use it, but don't worry, we can download any type of data from this. We open a connection. If there's error, we close it. If there's no error, we continue and copy rates from position. If the currency pair time frame, 0 means the most recent bar which is being formed, it's not closed, and bars. Yeah, I will get 100 bars, but in deep learning, we'll need at least 1000 bars. 100 bars will be too less. After we have opened the connection, we shut down that connection. And then we convert these rates into a pandas data frame and then return that rate. Now let's make our deep neural network. We'll be taking currency pair time frame bars. First, we use the rates function, and then we have a data frame. We convert time to date time. We calculate the return. We are using np.log. If you have watched my video on NumPy for algorithmic trading, where I explained np.log. We have got two types of returns. One is percentage return and one is log return. And log returns have got better statistical properties. So we try to use this log returns, but we can also use percentage returns. In this case, I have used log returns. So see, we have used, and then we find the direction np.where. If return is greater than 0, we give it 1, and if it is less than 0, we give it 0. Means if it is return is positive, it is 1, it is negative, it is 0. We use 5 lags. We use 5 returns before that to make our calculations. We get data, price, df.close, return. We add another column, direction. We shift it back instead of forward. -1 should be, know the difference between +1 and -1. Shift +1 is we shift the column one row forward. In case of -1, shift the column one row back. We calculate for lag in range 1, lags plus 1. We make this data. This is known as data pre-processing. We are now building a data frame. We now add momentum. Momentum is return rolling 5 mean. Returns means we take the returns 5 previous returns and take that average, and we say it is the momentum. Let's say we add the 5 returns, it's positive, we say the momentum is positive, and if the 5 returns we add is negative, we will say that the momentum is negative. Volatility, so return rolling, and we calculate the standard deviation 20 previous returns. We calculate distance, price minus price into rolling 50 minus mean minus shift 1. Means we present price with the price 50 back and then rolling 50 means we take it means. It's very important that we drop the NAs. Drop means was you'll calculate these things. Initial rows will have NAs, not a number. So NA will drop it, otherwise this model will just complain that there are too many NAs. So we drop it, we extend these columns, then we add up optimizer, add them, and model sequential. As I've said, sequential is one layer calculates, then it gives the second layer, calculates, it gives the third layer. So these are the layers we add. First we said sequential. First layer is dense 32 neurons. Activation is ReLO. ReLO is the activation function. We use that ReLO. Nowadays it's being used. And then we add another layer. Then again, it makes 32 neurons. And then we have the last layer, it is just 1 neuron. So we have added 3 layers. 2 layers use ReLO, 1 layer use sigmoid. And then we compile the model and we use binary cross entropy as loss. Binary cross entropy means that model is going to calculate the probability of each return, whether it is bullish or bearish, 1 or 0, and then compare it with that actual, whether it was 1 or 0. And if it is, it predicts that is 1 and in actual it is 0, then we penalize that model, right? So we then divide that data into training data up to the last, we remove last 2 bars. And then we normalize that data. It's very important that we normalize the data. Neural networks always love data that is between 0 and 1. So we normalize it using mean and standard deviation. And then we test data. Test data is last 2 bars. And we again normalize it, model that fit. And we make the prediction. Test data columns. If the probability is greater than 0.5, we'll say it's 1. And if it is greater than 0.5, less than 0.5, we'll say it's 0. Means if that probability is, let's say 0.6, we'll say it's bullish. And if it's, let's say like 0.4, and we say it's bearish. And then we return. So this was our model. Now let's use that model. Open the terminal. Run Python terminal interpreter. Okay, we have done it. Now this is the DNN file. I've defined these functions. I'm to import these functions through DNN. See, it's importing TensorFlow. It's saying that couldn't find that CUDA DLL, but since we have, I've told you I have not installed GPU, so we'll just use ordinary TensorFlow. Now we import this MetaTrader. We can use this H1, H2, H4, H8, H12. Let's run the model for daily time frame, and currency pair is euro yen. Let's read it. Currency pair is euro yen, and let's run this deep neural network. Time frame daily, currency pair is euro yen, and we download 1000 bars. Look, rapid calculation, epoch is one calculation, 0. What it means is that we will have, it's predicting a bearish bar. Okay. And let's see what it predicts on H12, 12-hour time frame. On daily, it's telling it's bearish. On 12-hour, it's telling it's bullish. This is the prediction of our deep neural network. How much accurate this prediction is, for that we'll have to back test. Once we back test with the last 10 years data, only then we can say that this model is 70% accurate, 80% accurate, 50% accurate, 60% accurate. So stay tuned. In the next video, I'm going to now show you how I'm going to back test this. Back testing is very important because right now we don't have any idea how much accurate this model is. So we will back test it. First, we'll train that model, then make this prediction, then make and compare that prediction with the actual result. And if we have got the same result with the prediction, so we have got a good prediction. And if we have opposite prediction, then we calculate for, let's say, like 5-10 years, and then we'll know how much accurate this model is. Right now, this model is saying that we will have a bearish candle on D1 and we will have a bullish candle on H12, means 12 hours. If you want, if you want to trade with this thing, let's see. And it seems to be correct because here we have got a bullish H12 bar, and only we have got 2 hours left before this bar closes. So model seems to be making the right prediction that we'll have a bullish H12 bar and we will have a bearish bar on D1. So stay tuned. In the next video, I am going to show you how to backtest this model, deep neural network model that uses TensorFlow, and measure its accuracy over the period of last 10 years. I hope you like my video.